As we enter 2026, the artificial intelligence landscape is no longer a single monolith. That peak has shattered into dozens of specialized, competing niches. We used to rely on marketed numbers, an MMLU score of 90%, or a processor claiming 80 tops. But in today's market, every top-tier model clears those legacy hurdles. Those figures no longer indicate how a model or a chip will actually behave when integrated into a professional workflow. Plotting the field by capability and cost, proprietary leaders like GPT-5 occupy the top right. They provide frontier capability at high API costs. But open weights like DeepSeek have narrowed the gap in the bottom right, delivering top-tier performance for a fraction of the expense. This compression makes model selection a game of thin margins. If you route simple data extraction tasks to a premium model, you pay 250 times more than necessary per API call. However, if you rely on a budget open weight for complex logic, your operations will likely stall due to reasoning errors. To find the right balance, we need to evaluate three distinct layers: the local hardware, the intelligence layer, and the execution harness. Success in 2026 is no longer about buying the highest spec component. It's about building a stack that matches your specific friction points. We'll start with the metal on your desk. The foundation of your stack is the local hardware, which is now split between specialized NPUs and traditional discrete GPUs. Neural processing units are designed for efficiency during low-latency, single inference tasks. If your work involves live audio cleanup or real-time background removal on a mobile device, an NPU handles that while preserving your battery life. But that efficiency comes with a throughput penalty. For batch processing 100 images or training a model locally, an NPU can take 70 seconds for a task that a GPU completes in 30. There is also a specific performance bottleneck that often determines whether an AI PC is actually functional: unified RAM. This chart compares local LLM performance across different memory tiers. A chip can market high processing power, but with only 16 gigabytes of RAM, the system lacks the memory overhead to even load the weights of a 7 billion parameter model. For any serious local LLM deployment in 2026, 32 gigabytes of RAM is the functional baseline. When choosing hardware, look past the marketing numbers. Match the compute type to your specific workload and ensure you have enough memory to keep the model in its active state. Moving up to the intelligence layer, the economics of cloud LLMs have diverged sharply. Open weights like DeepSeek v3.2 offer frontier-adjacent performance at 28 cents per million tokens. For high-volume processing, this represents a significant shift in sustainability. The trade-offs are specific. You face different data residency considerations and a drop in reliability when asking the model to manage autonomous tool use. On the other end, models like Claude Opus 4.6 or GPT-5 carry a price tag of $5 or more per million tokens. This matrix shows what that premium actually buys. While open weights handle standard coding, the proprietary models are necessary for deep multi-file reasoning, context windows that hold 1 million tokens, and agents that reliably execute 20-step tasks. Models like Llama 4 Scout offer a unique throughput of 2,600 tokens per second, but capturing that speed without recurring API costs requires you to manage your own self-hosting infrastructure. Using frontier models for simple scripting or high-volume summaries is a financial drain. Rent those models only when you need their specific edge case logic. The final layer is the execution harness, the code and scaffolding that connects your hardware and models to your actual output. On complex coding benchmarks, a bare model with standard prompting succeeds just 23% of the time. By wrapping that exact model in a specialized agent harness, success reaches 45%, providing the structural guidance needed to complete tasks. This requires a trade-off in setup. Harnesses like SWE Agent or Warp Grip demand complex IDE configuration and can disrupt your existing workflows. However, in 2026, the return on investment from optimizing your tooling often exceeds the gains from simply upgrading to a newer model. To build your stack, we have to look at your daily workflow. Everything stems from identifying your primary bottleneck. That answer defines your path. For some, the bottleneck is local hardware mobility. If you are an on-the-go creator, your focus is battery life and real-time processing. Your stack is an NPU-equipped Copilot Plus PC with at least 32 gigabytes of RAM, paired with lightweight cloud models like Gemini 3.1 Flash Lite to handle media tasks without constant recharging. For others, it's high-volume execution. If you are an agile developer, API fees are your bottleneck. You should swap proprietary models for DeepSeek v3.2 or Gemini 3.1 Pro and invest your time in a sophisticated agent harness rather than paying for high API volume. Finally, there is deep reasoning and autonomy. If you are a deep tech architect, your bottlenecks are reasoning limits and hallucinations. This requires an RTX 50 series GPU and premium reasoning from Claude Opus 4.6 or GPT-5, because open-weights struggle with graduate-level science and edge case logic. This represents perfect alignment. Every single layer of your stack is positioned to precisely support the others without any unnecessary friction. Chasing the newest model is a distraction. The real advantage in 2026 belongs to those who design the smartest workflow.